So going to be talking a little bit about today what we've been doing at Crunchyroll, because we've been developing a new video framework to kind of lay the foundation for all of our video efforts over the next couple of years. And I joined the team back in August, came in as the tech lead on the relaunch of our video framework, and laid a lot of groundwork for the video player that we are currently rolling out right now. We are in the midst of the launch of the new player on Crunchyroll and hoping to be in full deployment by the end of October. So who is Crunchyroll? So Crunchyroll, if you're not familiar with it, is pretty much the biggest anime video service in the world. We have 2 million paid subscribers and a number of non-paid subscribers who are ad-supported. We're one of the only services, just like Hulu, who offer both subscription models and ad-supported models. We have a unique situation where anime will come out in Japan. We'll get it on a Friday night. We have teams across the world that are translating that content into 8 different languages, and we'll have it live on our site within by Saturday in 8 different languages. Massive catalog. So we really needed to have a robust framework to support all of these video efforts. So where we were was looking at this from the perspective of we don't just want a player. We need to support, there are 3 brands under the Elation framework. So Elation's our parent company. We needed to support Verve, Crunchyroll, Rooster Teeth. Radically different experiences, radically different audience needs, but we wanted a framework where we could build things for it and use a common code base, but change functionality via configurable framework to get the experience that we wanted. We also wanted to leverage the ability to span across multiple analytics frameworks. We had issues with licensing costs with different analytics frameworks, and so we wanted to be able to turn on, turn off analytics frameworks, target our own internal analytics frameworks. And we also, a big thing that we were trying to do is say, okay, historically, we had a lot of different client teams. And so one client team is working on one feature, and we have to coordinate with that client team. We've got an Android team, and the Android team has to we build an API, we can expose some information, we want skip intro, we want an up next widget, then somebody builds an API to support that. The Android team says, well, do we have the bandwidth to tackle that? Okay, well, if we can consolidate into a single player framework, all of a sudden it falls on the player team, and the Android team, or the iOS team, or the web team doesn't even need to get involved. We just say, hey, we're rolling out a new version of this video framework. Let's go ahead and include this feature. Let's QA it across all of those platforms. We know the API works, and we're live. And we can do a simultaneous launch of those features. So where we were coming into this towards the end of last year was that we had rolled out a new video player. We went from a Flash player to an HTML player in about 2017, I think, 2017, 2018. And we hit a lot of limitations. It was hard to develop this. We were launching the Verve brand, and we had limited time, and so we had to jump into the project. And we built off of VideoJS 5. VideoJS is on, I think, version 7 now. And there was too tightly coupled with VideoJS. And so we couldn't upgrade the version of VideoJS. We were writing a lot of ES5 code. We didn't have a sense of state that was separate from VideoJS. So debugging was extremely hard. We'd have bugs. It was hard to launch a new version and ensure it didn't break anything. It was tied to an iframe. There were all these limitations. So it made sense to say, hey, what are we going to do now? And so a big part of the considerations that we were facing in this decision was, hey, we want to have a common code base that we can share across platforms. We want to have a single player, and we need to hit a lot of targets. Because we're such a large provider, we have to be able to support Wii, PS3, PS4, Xbox, web, mobile, Roku. And so with all of that, and with the resources that we have available, we need to make sure that we make the best use of those resources. And what that opened us up to was talking to a provider that's very popular in the TV space, U.I. They're an Ottawa-based company, and what they've done, for anybody that's not familiar with it, React Native is basically, it gives you a JavaScript way to build apps that maps to the native platforms. So you declare and you say, hey, I want a button, or I want a background. And React Native says, cool, I know how to do that on your platform of choice, whether that's web or mobile or a TV. And you're going to get the same widget, the same behavior. So the U.I platform is basically taking React Native and adapting it for TV platforms. And so we get to hit Roku, we get to hit Android TV, tvOS, Fire TV, Xbox, with a single code base that's tailor-made for TVs. And we don't have to deal with all of the development efforts of trying to hit all of those different platforms, which all have like relatively small user bases. And then on top of that, we're going to write this for this U.I framework. Well, why wouldn't we hit mobile and web while we're at it, right? React Native runs on those platforms, and it works really well. It's very mature. There's the React Native video library, which I've worked on quite extensively. And so we knew that if we went onto those platforms, we were going to do a pretty good job. So the idea was, let's build a React Native framework, get it running on all kinds of different devices, and we'll get all of the goals that we're looking for. So looking at this, what were we after? We wanted it to be modular, right? We wanted to be able to enable functionality for one brand or for one customer. We wanted to be able to say, hey, on TVs we don't want this feature, but on web we do. We wanted to take it and say, hey, we don't want to have to know about player implementations. We want to specifically have like a generic normalized player that we could hit so that when we say we got a paused event, we don't have to know all the nitty-gritty details. We want to be able to theme it so we could hit those brands that I was talking about earlier. We want to be able to create specialized behavior. Say, I'm on an iPhone, I don't want this. I'm on an iPad, I do want this. And we wanted to be able to leverage those native code capabilities. So if I have AirPlay, I have Chromecast, I want to be able to expose that, while at the same time not having to do all of the native code integration to do all the other stuff that is common between players. So Michael here, our VP of Engineering, worked at Kaltura. He provided a lot of guidance on this. The Kaltura Player, you basically have a huge repo with a lot of plugins in it. And in that repo, you can say, okay, I want a button and I want to put it here. So we started to follow that kind of model, but take it from Kaltura or Video.js, where those are web-specific frameworks and they work great on the web, but we wanted a cross-device framework. And from that, we wanted to say, we're plugin focused. I want to be able to take this piece of functionality and I want to be able to configure it, and I want to be able to take and talk to my APIs and say, on this platform, on this environment, on this device, let me have a specific configuration. So each plugin need to have its own configuration, need to be able to turn it on and off, and we need to be able to turn those things on in a very easy way. So just have some layouts where I can say, I want a pause button, I want a play button right here, I want to have a pause button in the middle of the screen. So layouts were important, and what we got from that is the ability to say, hey, when you build this feature, you're just building this piece. Let's not destabilize the rest of the system. So one of the things that we needed to do that sort of bore this out, right, and that we were looking at that's a really tricky challenge at Crunchyroll is subtitles. So when you look at this screenshot here, basically everything you're seeing is a Japanese, I think, kanji character. And so with a normal subtitle environment, right, you're dealing with captions, you're dealing with subtitles, you're saying, okay, I want to be able to just translate this into the user's language. But when we're dealing with anime content, most of the anime content is authored in Japanese, and you'll have these signs, right? You're walking by, the person's walking by a restaurant. We need to show them what that restaurant's name is. The person gets a letter from their girlfriend and she's breaking up with him. We need to see that letter on the screen. And that's really critical because anime fans are extremely discerning. So what does it look like when we put it into VTT? It looks like this. This is the stock VTT experience on the bottom right. And what we really want to hit is the experience that I have here on the upper left. And historically, VTT, especially when we're talking about like bridging across a lot of different devices, you're going to end up with these black boxes. And so what we've done is we're using internally the libass format. ASS is a format that was developed specifically for anime, and it offers incredible customization. And so you can say, I want shadows, I want outlines, I want strike-throughs. And where we ran into is like VTT is okay and it's developing, but it's not there yet. And it's certainly not there yet on native platforms for TVs and mobile platforms. So what we're doing is we're continuing to leverage the libass format, displaying it on the web, and displaying it in a web view today. And when we're moving towards a place where we can start to use VTT by displaying VTT, so the current implementations of VTT vary between browsers. And once you get off of the browser on the native platforms, the support starts to drop off pretty dramatically. So what we can do is we can kind of use a web view format where we're using the VTT.js renderer. And with the VTT.js renderer, we just need to be able to display some divs, load some CSS, and we guarantee that we get a consistent implementation. And we can use web views to hit mobile platforms and the web and get a consistent output. And then one of the things that we're trying to do with our framework too is leverage these native capabilities. So as we keep the ASS format, we're going to create like a native module so that when we hit a living room device until we're ready to go VTT, we just display a native overlay of the ASS format. Another thing that we were looking to do was there's a lot of evolution, right? We're used to like the bilinear filtering in order to upscale content if you're going from like 1080p to 4K. And that'll do a mediocre job. But what we wanted to be able to do is like do compositing and bring in different approaches. So specifically for anime, you need a different upscaling technology. And so we wanted to build like a framework that could do compositing and basically be able to plug in different modules and say, okay, Anime 4K, which the community has developed, is leveraging a lot of like neural network type of features specifically tuned towards anime and bring that in. So that's something that we're exploring right now, but we wanted to have that capability where we can say, okay, take the output of the video and draw it onto a canvas and pass it through a filter. And we're seeing that increasingly that's important. There's startups going into the space. There's a lot of support within GPUs. The advent of 8K TVs is making this really critical. And this is something that I'm hoping to talk to you guys about as we get further along with this and we get some audience feedback. So what do we do to develop this framework? The key pieces are React Native, which I mentioned before, the TypeScript variant of JavaScript. So TypeScript gives us a lot of very defined behaviors within the language. So when we're dealing with text tracks, when we're dealing with streams, when we're dealing with images, we want to have a consistent format that we can identify and say, whether I'm on a TV, web, or mobile, I want a common object format. And again, all we're trying to do is create a common language that we can talk and enforce that and force people to figure out how do we define a common representation. Another big part of this, I mentioned that we had difficulties with state. Redux is a very specific state machine. You provide an input and it outputs a new updated state. It's really popular in the React world. It's a very good fit for this because we say, oh, we paused, and that updates our paused flag. And we can see that, we can monitor it, and we can respond to those changes. And the last piece is Sagas, which is a very overly glorified event handler for React Redux environments. To do this, to bring all these pieces together, Yo plugins, we use this Dux pattern that is really popular within the Redux community. So all of our functionality is grouped into a plugin, and then we need to be able to have behaviors that are specific to a particular platform. So we say, okay, we're going to have some business logic that's shared, and then we branch out into per platform business logic to integrate with AV Player needs this, Safari needs this, Chrome needs that. In terms of configuration, we started with JSON Schema. JSON Schema, you can create a schema, you can validate it. One of the key things that we wanted to do was to be able to provide this config and have people be able to look at it and see what the properties that are available. And so you can define, here are the input values, here are the allowed parameters around this, some commonality stuff around like, okay, every plugin is going to support being enabled or disabled. And so this was a good way to expose that in a very standards-oriented way. We really wanted it to be flat so that you're just looking at, in a plugin, I have these parameters and I can toggle them on or off. In order to achieve like different look and feel on different platforms. We created layouts. And so the idea with layouts is you just declare the pieces that you want, and then you use configuration to define how those pieces work. So we can have a layout for TVs, we can have a layout for 720p and 1080p, we can have a layout for an iPad versus an iPhone, and especially it's common, we wanted to separate it and just focus on functionality. Put it in the layout, it's on. And this was primarily targeted towards our UI components, where, behavior of business logic, that's handled via config. Layouts just say, I want these UI elements on the screen, and then we have like a theming engine that allows us to say, how big are they, what color are they, what fonts do they use? So the biggest part of this is trying to get to a common interface. And so when you're dealing with all these different players, right, at the lowest level, we have some kind of native player engine. We got a PS4 and an Xbox. And all of these frameworks that we're leveraging provide an abstraction on top of that. So the U.I platform has their own video player. React Native Video abstracts both AV player and XO player on mobile platforms. And the HTML video element abstracts all of the different browsers. And so we don't have to worry about those lower level implementation details for the most part. But still, we got to translate and say, well, we got HTML video over here, and we got React Native video over here. And so what we modeled after was the HTML video element, because that is the most well-defined. If you're using any of the 4 major browsers, they behave mostly identically, and there's really good documentation. It's a really mature implementation. So we said, let's normalize everything over to HTML video, and we'll know also that that's a pretty mature spec, so it covers almost everything, and we can just add the bits that we need. Same thing with our APIs. So when we want to seek, when we want to pause, go ahead and look at that HTML video element and try and normalize to that. And a big part of this is like kind of coming up with events. So like when we want to go full screen, when we want to pause, right? If I want to pause or I want to play, I have to ask permission from the browser. And so we'll say, hey, I need to request that I play. And then the browser is going to either say, I reject that you play, or I enter a playing state. And so we normalize that, even though on like mobile platforms, you don't have that. We can still say, we still have that concept that I requested play, but on iOS or Android, there's no autoplay permissions. So it's just going to play. And out of this, we got really good results on our code sharing. So our goal was to have as little platform-specific code as possible. We only want that when there are differences in behavior. So we've got our themes, we've got our layouts, we've got things where Safari needs this little tweak. So let's go ahead and add an if-def statement in our code, and we hit about, 80% code sharing, which is really nice, because as we fire up another platform, when we fire up on Android and iOS, right now we're focused on web and living room, we're pretty much there. We're just filling in those little platform bits, and otherwise we're really close to shipping. Another big concept that we ran into is, right, you've got a lot of player events. If you've worked with the HTML video element, you've got play and playing. I don't even know what the difference between those two is. And then you have a number of events. We've got that we've started loading, and now the metadata is here, and now we've got the data. And as a plugin implementer, you don't want to know the entire HTML video spec. You just want to know, I'm displaying some text tracks. Tell me when that video is playing, and give me some time updates, and my implementation is going to draw some subtitles on the screen. So what we did is we created like these lifecycle events and these synthetic events that are representations of the key events. And so we say, okay, you know what? I don't care about loaded data and loaded metadata. Just tell me when I'm ready to play. I don't care whether I entered a buffering state or a waiting state or I paused, right? All of those result in pause. And so by exposing these simple subset of events, it makes it easier for new developers to step in, and it allows you to think about those things and adapt those things and introduce new conditions, new pause condition. I had an error. My video crashed. I hit the stop button. All of those things all result in a video stopping playback. And we can subscribe to video stop playback and respond to that. And that allows us to iterate very quickly. So with all of this, you know, one of the things that we did, as I mentioned, is that we wanted to be able to deploy across multiple platforms. So we're in the process of developing a skip intro feature, which is a huge request from fans. And historically, we would have had to say and coordinate and say, hey, Android guys, do you have some time that you could support this? And, you know, we would end up building the UI twice or 3 times or 4 times. And then we've got to make sure that they do the API integration and verify out that they did their API integration. And like with the approach that we have now, we can basically use the same button and say, okay, you know, skip intro button, it's going to be on the bottom of the screen on iOS. It's going to be on the top right on web. You turn it on, and literally, like, we can potentially be, we need some QA, and we can potentially be releasing that feature within a matter of a week on those different platforms simultaneously with a higher level of quality than we would have achieved if we had 4 different implementations, because we can give it extra time and a single QA cycle to validate that it works. Another thing that we've been doing, we're in the process of moving to a server-side ad integration. So that's basically where the ads are in stream. Historically, we've done client-side ads where you have an SDK, you have to have a lot of different SDKs. SSAI is a much better implementation because we can partner, and the partner is responsible for talking to the ad networks. We can offload the ad orchestration of figuring out who's going to provide the best CPM, and all we're responsible for doing is displaying the ads, or the controls rather, when the ads come on the screen and providing the right messaging. And so what we can do with the architecture that we've developed is we have just a single ads framework that says, okay, I've got an ad break start, I've got an ad start, I've got an ad end, I have a duration for the ads. And actually, we built an ads framework where we can just toggle with a single text string change, going from a client-side ad solution to a server-side ad solution, and getting exactly the same UI, exactly the same behavior, and exactly the same analytics that we would get from either service. And lastly, one of the things that's really exciting about this is from the beginning, we've looked at this from being able to support multiple brands. And the ultimate evolution of that is taking this to an open source release. And initially, what we see is we built this for web, and we're currently in the process of building it for TV platforms. So where does this fit? It fits largely for our fans. We have really engaged and dedicated fans, and we want to expose the code base so that they can make improvements and suggestions and prove to them that we've really done everything we can to give them great experience. Over time, as we build out the framework and we have the development cycles, we're going to expand this so that it can be a full-fledged video framework across all of those platforms that I listed, and ultimately be a competitor and also an inspiration to Kaltura and Video.js. Thank you.